Introduction to Object-Oriented Programming, OOP. Welcome to this quick tutorial on Object-Oriented Programming, or simply, OOP. If you've ever worked with modern programming languages like Java, C++, Python, or C#, chances are, you're already using OOP, even if you didn't realize it. So what is OOP? At its core, object-oriented programming is a method of organizing code by grouping data and functions into logical units called objects. These objects are based on classes, which act like blueprints. Let's quickly break down the 4 key principles of OOP. Encapsulation, bundling data and related actions together while restricting access to some internal parts. Abstraction, focusing on what an object does without worrying about how it does it. Inheritance, allowing a new class to inherit properties and behaviors from an existing class. Polymorphism, enabling one interface to be used for different data types.
Let's look at a simple example of encapsulation in Java. Here, we have a class named person. Inside this class, there is a private variable called name. By declaring it as private, we are restricting direct access to this variable from outside the class. This is the first step of encapsulation, hiding the internal state of an object. Pause briefly for the code to highlight private string name. Now, to allow control access, we have created 2 public methods, a getter method called getName and a setter method called setName. The getter allows other classes to read the value of name. The setter allows them to change the value, but only through this method. Highlight the getter and setter method visually. This design gives us control. For example, if we later want to add validation, like making sure the name is not empty, we can do it inside the setName method. So instead of accessing the variable directly, we use these methods to safely interact with data. This is the key idea in object-oriented programming. Keep your data protected and only expose what's necessary. Now let's explore abstraction, another core concept of object-oriented programming. In this example, we have an abstract class called animal. An abstract class is like a blueprint. It defines what should happen but not exactly how it happens. Highlight abstract class animal. Inside the class, there is an abstract method called animal sound. This method has no body. It is just a declaration. Focus. Public abstract void animal sound. That means any class that extends animal will be forced to define its own version of animal sound. At the same time, this class also includes a regular method called sleep, which prints C's. This method has a complete body, so it can be used directly by subclasses without needing to change it. Also, public void sleep, system.out.println C's. This mix of defined and undefined methods is what abstraction is all about. It lets you hide complexity and force structure in your program. The abstract method sets a contract, like saying, any animal must make a sound, but you decide what that sound is. For example, a dog class might implement it as woof, while a cat might return meow. Let's now take a closer look at inheritance, one of the core principles of object-oriented programming. In this example, we have a class called vehicle. Inside it, there is a protected attribute called brand with the value Ford and the method called honk that prints a simple sound. Pause for code highlighting. Protected string brand equals Ford and public void honk. Then we have a second class called car, which extends vehicle. This means that car is a subclass and it inherits everything that vehicle has, all its attributes and methods. Pause to emphasize. Class car extends vehicle. Inside the car class, we have added a new attribute called model name, which stores the value Mustang. Now, here's what happened in the main method. We create a new object called myCar from the car class. Pause. Car myCar equals new car. Then we call the home method on that object, even though the method is defined in the parent vehicle class. It works because the car class inherits it. Pause. myCar home. Finally, we print out the brand, which comes from the parent class, that the model name, which is specific to the car class. Let's talk about polymorphism, the fourth core concept of object-oriented programming. Polymorphism means many forms. It allows the same method to behave differently depending on the object that calls it. In this example, we start with the base class called animal. It has a method named animal sound, which prints a generic message. The animal makes a sound. Then we create two subclasses, pig and dog. Each one overrides the animal sound method to provide a unique behavior. In the pig class, the method says, the pig says, wee wee. In the dog class, it says, the dog says, wow wow. Even though the method name is the same in all the three classes, the actual output changes depending on which object you are working with. That's the key idea. With polymorphism, one method name can lead to different results based on the object that's calling it. Polymorphism helps you write code that is flexible, extensible, and easy to manage. It is a powerful tool when you want your program to behave differently without changing the method name. Together, these principles make your code modular, secure, and easier to maintain, especially in large projects. Thank you for watching this video. We hope you found this introduction to object-oriented programming insightful.